In this video we are going to look at work done and power. We are going to look at the definitions of both of those terms, what they mean, and we're also going to look at how we can calculate work done and power. We are going to start with work done. Work done is the energy that is needed when a force moves an object over a certain distance. So for example, if you push a wheelbarrow over a certain distance, you use a force, and the work done here is the energy that you need to do this. The equation to calculate work done is work done equals force times distance. The unit for work done is joules, the unit for force is Newton, and the unit for distance is meters. We can also write it as E equals F times D, where E is the symbol for work done, F the symbol for force, and D the symbol for distance. Now we're going to look at an example. A boy is pushing a wheelbarrow. He pushes it 3 meters along a ramp using a force of 200 newtons. Calculate the work the boy has done. So now we need to find the value for force and the value for distance given in this question. And the distance here is 3 meters and the force 200 newtons. So those two numbers we need to plug into our equation. So we get work done equals 200 newtons times 3 meters, and this gives us a work done of 600 joules. Now let us look at a second example. A horse pulls a cart. It uses a force of 900 newtons and pulls for 200 meters. Calculate the work the horse has done. Now you can pause the video, grab a piece of paper, and have a go at calculating the work done for the horse yourself. You can use the equation for work done at the top. The force that is given here is 900 newtons and the distance is 200 meters. So those are the two numbers we need to plug into our equation. So we get work done equals 900 newtons times 200 meters, and this gives us a work done of 180,000 joules for this horse. Now we're going to move over to look at power. Power is the rate at which energy or work done is transferred, or more simply put, how fast energy or work done is transferred. The equation to calculate power is power equals energy divided by time. There's a second equation we can use to calculate power, which is power equals work done divided by time. The unit for power is watts, and the unit for time is seconds, and energy and work done both have the unit joules. Again, we're going to look at an example. A car has a weight of 10,000 newtons. A man takes 10 seconds to push it 5 meters. Calculate the work done and the power. This is a very common question that you have to calculate both work done and power. And if we get a question like this, we always have to start with calculating work done first, because then later we will need work done to calculate the power. So we are going to start with work done, and we are going to look back at the equation for it. It was force times distance. So now we have to find force and distance in this question. And the force here is 10,000 newtons and the distance 5 meters. So we get work done equals 10,000 newtons times 5 meters. And this gives us a work done of 50,000 joules. Now that we know work done, we can move on and calculate the power. So remember, power equals work done divided by time. We already calculated work done. It was 50,000 joules. So we now have 50,000 joules divided by time. And the time given to us in this question is 10 seconds. So we get 50,000 joules divided by 10 seconds. And this gives us a power of 5,000 watts. Now we're going to change the question slightly. Another man pushes the same car over the same distance, but takes twice as long. How does this affect work done in power? To answer this question, we need to look back at the equations to calculate both. So we're going to start with work done. The equation to calculate work done was force times distance, and when looking at it you can see that time is not included in this equation, and this means that time does not affect work done. So work done is not affected by the time, it is still the same, which is 50,000 joules, as we calculated earlier. But what about the power? To calculate power, we need to take the energy or work done and divide it by the time. So we said work done is still the same, it is still 50,000 joules, but now we need to put in the new time. So before we had 10 seconds, and it says that now it takes twice as long. That means we have to times those 10 seconds by 2, and we get 20 seconds. So the new power is 50,000 joules divided by 20 seconds, and this gives us 2,500 watts. So the power actually has changed. What we need to remember from this is that power is affected by time because it is part of the equation, but not work done. Work done stays the same. Now we are going to look at a slightly easier example. A girl runs up a high flight of stairs in 10 seconds. She does 1,500 newtons of work. Calculate the power of the girl. So in this case the work done is already given to you, and so is the time. So now you can pause the video, grab a piece of paper, and use the equation above to calculate the power of the girl. So the work done for this girl is 1,500 newtons, and the time is 10 seconds. So we get power equals 1,500 newtons divided by 10 seconds, and this gives us a power of 150 watts for this girl running up the stairs. And this is all you have to know about work done and power.